So this is my main variable power supply. It's great, but it's limited to 30 volts, 32 volts, and 10 amps. I often hit the 10 amp limit when messing with high power stuff. So it would be great to have a beefier power supply that I can use for driving large motors and whatnot. Now I do have a large number of these servo power supplies. In fact, here is 8 of those large servo power supplies. These power supplies are rated for a kilowatt each at 12.5 volts, 82 amps. In total, that's 656 amps if I were to put all of these in parallel. I got them for 15 euros each. They're very cheap. If I break any, I can replace them quite easy. You can see I've made some modifications. I've added some 8mm bullet connectors on the front here, on the terminals. I've added a little enable switch, and internally these are now floating. So these 3 screws have been replaced with plastic screws, and there are also plastic washers. So I've disconnected this ground from earth. The chassis of this is earthed to the earth pin, so these power supplies are now floating. So I need a way of taking all these power supplies and turning them all on and off at the same time. So I want to build a power distribution unit on top of this. I'll make a nice steel box or something and plug some parts into it. So I've got some stuff marked out on this sheet which you can't really see very well, and now I'm going to cut it out using this nibbler. You can see on these corners there's a small piece. That's what this actually rests on, so the bottom stays open. Lives on top of here like this. So I've decided to solder all these connections because I'm really not a fan of spade connectors. It's just a personal preference thing. I find they get really jammed on there, whereas solder, I can just melt it. So the great thing about this design over just a more powerful variable power supply is it allows me to run multiple circuits separately. So I've got a 24 volt motor here being powered by 24 volts. That's 2 servo power supplies in series. And then I've got a universal motor, a 240 volt universal motor here from a vacuum cleaner, which is obscenely loud. And I'm running it off 36 volt DC, and that's like a totally separate circuit. And then I've also got this light bulb plugged into the mains outlet on the front, and I can turn them all on and off with this button. It's 92 decibels. Okay, so I've wired all these power supplies up in parallel here with this 16 square mil cable. This is 16 cables in total. There's 2 for each. There's 8 power supplies, and they are bussed up to this 70 square mil cable. We've got a shunt resistor on the positive side on the 12 volt, 12.5 volt. This is made up of 2 500 amp shunt resistors, 75 millivolt, to make a 1000 amp shunt resistor, so we can use this 1000 amp meter to measure our current when we start to pull higher currents in a moment. This negative terminal is fairly crude, but it should suffice for what we're doing. My workbench is conductive, so I need an insulator. Okay, so we're going to start off with something simple. This is a steel cable tie made of stainless steel. I've curled it and put some ends on so I can make good contact with it. This is made of stainless steel, much higher resistance than copper. Should give us a nice result. Might glow, I don't know, how much. Pulling 4 amps from the wall, that's not very much. Just glowing at the contact area, and I can feel some heat coming off of it. Oh yeah, we're just starting to glow now, look at that, isn't that pleasant? There is a possibility that I crack this tile, I don't know exactly what it's made of, I found it on the street. Alright, so let's do something a bit more current intense then. Okay, so this is a graphite rod, just pure graphite. $14 amps, 15 amps from the wall. 25 amps. We pulled 25 amps from the wall momentarily there. You can see just how crazy hot that gets. So you could see we were drawing a couple hundred amps. Let's wow, that's too much. Seems like when the graphite gets hot, it really makes good contact. Oh my god, we've melted the copper, look at that. Yeah, so the awesome thing about graphite is I'm not going to touch it because it's very hot, but have a look at it. There's no blemishes on it or anything. So you can see we're slightly pitted on one end and not at all on the other end. And that is entirely... So this melted the copper away, but hardly touched the graphite. Graphite is such a great electrode. So steel wool is a pretty obvious classic. We've got some steel wool here. I'm not going to touch it actually. When you pass current through steel wool, the resistance just makes it burn. So bring this ammeter in place. Probably won't see a ton of current, but who knows. Man, this cable is hot now. Anyway, so this should pretty instantly... Oh look, I barely touched it and it just went up. Look at that. So this nice fine stuff is very easy to light. Look, this is just a 9-volt battery. It'll output a few amps. You do that and it's lit. But this stuff is much coarser and I want to know, can I light this using my power supply? So 9-volt battery on there is going to do nothing. It's just a short, but it's not enough current to light this. So I want to know what happens if we hit it with up to 600 odd amps for a short period of time, Wow. This is really coarse as well. So it doesn't burn like the finer stuff, but this just goes for it. Isn't that fun? We're only pulling about 10 amps from the wall at most. Look at that. Wow, that made me jump. So that was the bolt making contact. Look at that. It's just part of the little tiny bit of the bolt missing. Let's short out the copper. I want to see what happens to the copper. Oh, not much. Wow. Wow. Okay, so on that last short, I was holding this. I felt this tug, like I got a pull in that direction. That was strange. This thing like tugged on my hand because of the magnetic field. That's ridiculous. Okay, so this right here is a bar of ferrocerium. You know what, let me demonstrate what ferrocerium is. When you're camping and you want to start a fire, you can carry some ferrocerium with you. Fire striker, sometimes they're called. And just peel off a little bit and it'll give you a spark so you can start a fire. Wow. Mmm. Wow. That's awesome. Interestingly, the copper is in good shape. So I think this is to do with the polarity. If I had this the other way around, the copper might be in a lot worse shape. Just want to make slight contact right here. Wow. That is so bright. Wow. Oh my God. This right here is my extractor. I have it super close because the amount of garbage coming off this is insane. Got a little bit welded there. This is ridiculous. Holy moly. Wow. My tile just broke. Wow. Man, that was loud. That was so loud. This huge tile, which I found off the street, so it doesn't cost me anything, just exploded because of the heat concentrate. So this is called thermal shock. When you have one area of a brittle material get really hot and expand, and the other area does not, the rest of the material does not expand because it does not get hot, then it breaks. I was kind of expecting this to happen. I've done hot stuff on this tile before and it hasn't broken, so I wasn't like expecting this to guaranteed happen, but I knew it was likely. I'm not surprised by this. You can see this strange buildup of powdery stuff. I'm not sure what it is. Ooh. Ooh. As I'm exposing new parts of the material to the oxygen, you can see it starting to burn like that. This is awesome. This is why I have a steel desk, because this tile breaking, no big deal, the desk can handle the heat. So somehow a piece of that tile ended up embedded in the remains of that ferrocerium stick. Okay, I've cleaned this tile up a bit. It's pretty blown up, but that's okay. I'm going to keep using this tile. There's no point in breaking the other one. That's still a good enough insulator for now. Okay, so I've got a strong magnet here. It's very small, but for its size, it's quite strong. I'm just going to put that about there. Currently, it's attracted to my steel desk underneath this. But watch what happens when I short this out. This is obviously quite bad for the power supply. I'm probably doing some damage here, so I won't be doing this very much, but watch this. Look at that. Look at that. Look at that. It just jumps so far. It's probably this coil magnetizing the workbench. I'm not sure exactly what's happening here, but it's awesome. Look at that. If I turn it upside down, then it jumps like crazy. Look at that. So right now it's attracted to the workbench, yeah. And this orientate, so that's north or south, and that is also north or south. So if I put it that way up with the chip, that chip pointing upwards, you don't get much response. But if I flip it over, so that chip is now sort of pointing downwards, then it jumps. Look at that. That's so cool. That is mad that just one loop of a coil can do that. That's amazing. So shorting this out, it looks like it's damaged this power supply. You can see these fans, that fan barely runs and this one only runs for a moment. I'm going to check the status LEDs on the back. Yeah, that one's dead. Yeah, this power supply has died. I'm going to deactivate it. So that's okay. These power supplies are very cheap, so I can replace it, no problem. Okay, something else I want to try. This is my pot of just random springs. So springs kind of make okay heating elements. They're pretty low resistance. Steel is not a great conductor, so you can use a spring as a heating element in a pinch if you need to. I don't know what resistance this has. I don't know if this is going to be a problem, but let's find out. Not much current. Yeah, the steel is starting to melt. There you go, it's gone. Look at that. And it's disconnected. Okay, I've unwound two quite fine wire walls. Wow, the heat coming off of that is incredible. Wow, that is so hot. That's awesome. Made me jump. So I've got some tinfoil set up on the worst stand that I own. That's amazing. Wow, that was so bright. Wow. Alright, so this is where this power supply is going to live from now on. I'm probably going to remove this assembly off the front. It's a bit bulky and large and I don't need that much current. For the next video, I really want a website that has a video feed of one of these hard drives. Now this is a hard drive that I've taken the top off and replaced with a piece of polycarbonate. I want to be able to control the head, the read and write head of the hard drive on the website. I love the idea of going onto a website and having control of things on the other side of the world with a slider. You know, that is really satisfying to me. Subscribe if you want to see me struggle with this. This is going to be kind of challenging. Thanks for watching. Goodbye.